Children, as we know in symmetry, it's a line. It's the line by which the whole figure divides into two mirror identical parts. Children. For example, if we have a rectangle, if you have to bisect any of the sides, this will be mirror identical part, children. Perpendicular bisector of this side and perpendicular bisector of this side. Same way, perpendicular bisector of this side will be the second line of symmetry. And this, children, this will be the point of symmetry for this figure, because if you rotate it 180 degrees, if you rotate this 180 degrees, children, it comes out to be the same figure. This will be the point of symmetry O for this figure. Now, children, question says, using ruler and compass only, construct a parallelogram ABCD such that BC equal to 4 centimeters, diagonal AC is 8.6 centimeters, diagonal BD is 4.4 centimeters. So let's write that down as a question. Using ruler and compass only, construct a parallelogram ABCD such that BC equals to 4 centimeters, diagonal AC is equal to 8.6 centimeters, and diagonal BD equals to 4.4 centimeters. Mark the point of symmetry of the parallelogram. Draw all lines and points all lines and points of symmetry. So we draw a rough diagram for this. That's BC is 4 centimeters. AC is 8.6 and BD is 4.4. So children, from here we mark 2.2 and from here we mark 4.2. From here we mark 8.6 half, that's 4.3, come somewhere over here, and then we extend this beyond, double the length, and that, children, comes out to be the parallelogram. Because, children, the property that works over here is diagonals are bisected. The diagonals bisect each other. So that's 4.3 centimeters and 2.2 centimeters. That's A, B, C and D. Now children, what we do over here is we draw the line BC 4 centimeters. That's BC 4 centimeters and keep here, mark 2.2 and then from here mark 4.3, which comes somewhere over here, children. Now we'll draw the lines. And then we mark 8.6, children. And we connect it. So children, this comes out to be A, B, C, D. Now children, for a parallelogram, no lines of symmetry are possible. There are no lines of symmetry possible for a parallelogram. The only possibility is the point of symmetry, which we'll mark it as O here. This point is to be marked as point O. This is the point of symmetry. So 0 lines of symmetry. and 1 point of symmetry. Let's see another example, children. Question says construct rhombus ABCD of side 4.6 and angle 135 degrees. You indicate the point of symmetry and draw all its line of symmetry. So construct a rhombus ABCD of side 4.6 centimeters and one angle as 135 degrees. Draw all its lines of symmetry. Draw all its lines and points of symmetry. So children, a rough diagram for this would be a rhombus. This angle comes out to be 135 degrees. This is A, B, C and D. And side is 4.6 centimeters. All sides are equal. So children, here we begin with, let AB be 4.6. That's AB length 4.6 centimeters. Then we construct, children, 135. That's 60, 120 and 90, and we draw the line. And then children, we bisect the angle, this being 180 degrees. We bisect the angle between these two. So we keep it here and mark, and keep it here and mark, and that, children, would come out to be 135 degrees. Now children, we'll mark 4.6. We'll take this measurement 4.6 and mark, and from here 4.6 and mark. That'll come out to be somewhat like this, children. That's A, B, C and D. Now draw its points of symmetry and line of symmetry. For the line of symmetry, we will draw the diagonals. Diagonals are its lines of symmetry. Always remember, children, the line of symmetry is drawn dotted with arrows at both ends since it extends till infinity. That's one diagonal. And then the other diagonal, children. Come down over here. This is the line, second line of symmetry. And this, children, this would be the point of symmetry. So children, lines of symmetry, diagonal AC and diagonal BD, and point of symmetry, point O. It's a point by which the whole figure is symmetrical, children. It's a point by which the whole figure is symmetrical. Like if I draw any line over here, if I draw a line over here, this measurement from here to here will be equal to measurement from here to here. So it is a point of symmetry for this figure. Let's see the example, children. Question says, on a graph paper, mark points A -2, 4, B 2, 1, C -6, 1. Draw lines of symmetry of triangle ABC. Mark a point D such that the lines in one in A are lines of symmetry line of symmetry and BC are both lines of symmetry for quadrilateral ABCD. So children, the question says A has coordinates negative 2, 4. That would be somewhere over here. That's A has coordinates negative 2, 4. B has coordinates 2, 1. So 2, 1 would come somewhere over here. That's B with 2, 1. And C has coordinates, children, negative 6, 1. So somewhere over here, C is negative 6, 1. Draw lines of symmetry for the triangle ABC. Mark the point E. So lines of symmetry for this, children. First we'll draw the diagram for this. It will come out to be if we connect it. Now children, if you look at this closely, the base is from this point, from this line, it's 1, 2, 3, 4 units and 1, 2, 3, 4 units. So this is the line of symmetry, children, for the figure. That's x is equal to negative 2. X is equal to negative 2 is the line of symmetry for it, children. Now they say draw this line of symmetry. So this is the line of symmetry. This is line of symmetry for the triangle ABC. And BC are both lines of symmetry. So now children, when you say BC line of symmetry, point A is 1, 2, 3 units up. So the reflection would come out to be 1, 2, 3 units down over here. So the coordinates of D, children, would come out to be negative 2, negative 2. And this, children, as a figure, this as a figure would come out to be a rhombus, because these are at right angles and this diagonal is not equal to this diagonal. The diagonal, this length is 6 and this is 8, so they are unequal, children, and that only happens in a case of a rhombus, and all sides are equal. Well, they haven't asked us for the name. If they would have asked us, we would have specified quadrilateral ABCD is a rhombus, and the lines of symmetry is x is equal to negative 2 and y is equal to 1. Thank you, children.